I am Dr. Yamuna from KIT Kalanyar Karunanidhi Institute of Technology. Today's topic is on ancient architecture and civil engineering concepts. What do you mean by Vastu Sastra? Vastu Sastra is an ancient Indian system of architecture that integrates science, art, astronomy, and environmental principles, which is used to design buildings in harmony with nature. The term Vastu means dwelling or building, and Shastra means science or knowledge. The main objective of this Vastu Shastra is to achieve harmony between nature and built environment, to ensure structural stability and functionality, to improve environmental comfort and energy efficiency, to enhance human well-being and sustainability. Let us talk about five elements theory. The five elements are the Panchabhuta, that is earth, water, fire, air, and space. In Sanskrit, we call earth as Prithvi, water as Jala, fire as Agni, air as Vayu, space as Akasha. Each element has got its own characteristics. Earth depicts stability and solidity. Water, that is Jala, it denotes flow and life. Fire denotes energy and heat. Air denotes movement. Space, Akasha, means expansion. What is its role in architecture? Earth denotes in architecture as foundation and walls for water, water bodies and drainage. Fire or Agni for kitchen and lighting. Air, Vayu for ventilation. Space is for open spaces. Now coming to the Vastu design process. This Vastu design process, the first thing is they have to look into the site selection. Then they have to orient. Finally, they have to divide into different zones, structural designs, and finally, sustainable building will be evolved. Now, the engineering significance of Panchabhuta, the earth. Let us talk about earth Prithvi, which determines soil strength and foundation design, which influences bearing capacity and stability. Whereas water or Jala influences groundwater recharge and drainage systems, which is very important for sustainable water management. Agni, the fire, is related to thermal comfort and energy efficiency. Air determines ventilation and indoor air quality. Space, the Akasha, influences spatial planning and built layout. Now coming to the orientation and design principles, it is very important that the positioning of a building with respect to the cardinal directions. So the directions are east, west, north, south. The significance, let us see the significance of east. It denotes sunrise and knowledge. As per architectural application, the main entrance or study room should be in the direction of the east. Whereas north, which denotes prosperity. So architecturally, we have to plan a house where offices and treasury are kept in north directions. The south depicts strength. So we have to keep our bedrooms towards this direction. Whereas west shows stability, where storage rooms have to be arranged in this region. Coming to the design principles in Vastu, the zone of spaces is based on the functions like symmetry and proportion in layout is a must. Natural lighting and ventilation, balance between built and open spaces, integration with natural environment. Modern engineering perspectives. Modern architecture applies similar principles through green building design, passive solar design, sustainable urban planning, smart building orientation. Coming to the benefits, by doing a design principle as per Vastu, we get an enhanced durability of structures, improved thermal comfort, psychological well-being, and environmental sustainability. A very good example is our ancient temples and forts show perfect harmony between structure and environment. Now let us see the temple architecture. The temple architectures represents a combination of religious beliefs, artistic excellence, engineering skills, and scientific planning. The two major architectural styles are the Dravidian style, that is South Indian style, and Nagara style, that is called as the North Indian styles. In the Dravidian style of architecture, the main characteristics are it is pyramid-shaped towers. We call it as Vimana. It has got a large gopuras where the gateway towers are associated. The mantapas, called as the pillared halls, have and extensive temple complexes which are all made out of granite stone structures. This is one of the characteristics of an Dravidian architecture or Dravidian style. The main structural features of this are they have a good load-bearing stone walls, massive pillars, interlocking stone masonry, and advanced foundation techniques. What's the engineering significance about this is it has got high seismic resistance, long-lasting durability, climatic adaptability. Now coming to the Naga style of architecture, it has got a curvy linear tower, what we call it as Sikhara, the square sanctum, that is the Garbhagriha, then minimal gopuras are present when compared to that of the Dravidian style, and they have used sandstone and marble for their construction. Coming to the temple construction process, usually first before the start of a temple construction, they need a plan. Then the foundation is taken care of, stone shaping using manually they were chiseling the stones, then interlocking masonry pattern was followed, and finally they completed the process of construction. Coming to the materials and structural designs, mostly if you see this, they have used granite, sandstone, marble, brick, lime and mortar. The structural technique what they have followed are interlocking stone joints, corbelled architectures, load distribution through pillars. So this structural longevity was due to the quality of the material, interlocking design pattern, the climate adaptation and strong foundation which led to the durability of the architecture. Advantages are resistance to weathering, minimal maintenance and high durability. Coming to the very good example, as I showed you, the Brigadishwara temple, which is located in Tanjavur, Tamil Nadu, as during the Chola dynasty, 11th century. The architecture feature shows that its height is 66 meters, built with granite blocks, massive vimana, and perfect symmetry. The engineering marvel are precision stone cutting, no modern cement were used, advanced foundation systems, nearly massive dome structure, a weight of around 80 tons. Its significance are UNESCO World Heritage Site. This Brigadishwara temple has been given a prestigious position what in UNESCO called as World Heritage Site, example of advanced ancient engineering, inspiration for modern architecture. Now coming to the water management, traditional water management. They had a very well planned collection of water during rainfall. Then they stored it and recharged the groundwater, and further it was being distributed to the public. Coming to this, let us talk about the examples, few examples like step wells. What are step wells? Step wells is nothing but it's an underground structure built to store and access water as and when required. Coming to functions of this is mainly water conservation, cooling effect, community spaces. Engineering pattern is a multi-level steps, stone masonry, structural stability. Next comes is the temple tanks. This is also one type of rainwater harvesting system they followed. It is mainly for ritual use, water storage, and groundwater recharging. The purpose was solved, and many people were utilizing this instead of traveling a long distance to fetch a pot of water. Coming to the structural design, this structural design is stone-lined walls, rainwater channels were kept, and large storage capacity. Coming to the rooftop, as of now, what we are using is traditional method. Apart from that, rooftop collections, reservoirs, and percolation pits. Coming to the Harappan town planning. The Harappan Indus Valley civilization is known for its advanced urban planning and engineering. Major cities are Harappa, Mohenjo-daro, Dholavira. They followed a grid patterned roads. So they had a very good planning of roads. Then zonation was very excellent. Drainage system was neatly planned. Sanitation was very good, which led to a sustainable city. This is the pattern which shows the grid system. So it has got an rectangular street layout. Main and secondary roads were there, and planned zoning was also neatly depicted in this diagram. Efficiency, because of this, there was an efficient traffic movement, organized urban layout. Coming to the drainage system. This drainage system is a covered drains. Usually brick-lined channels were used. It is used to maintain drain collections. And main significance of this is the advanced sanitation, hygienic and urban living. So they had a very good lifestyle. Now coming to this urban sanitation. So they were using public baths, what we call it as great baths, waste disposal systems, and planned toilets. These are the diagrams showing you the public baths. These are the Harappan Mohenjo-daro toilets, squat toilets, where they were using it. It has got a flush and squat type of toilets. This is very advanced. Even before 3500 BC, they were using this. So from this, we could understand that how modern they were in those Harappan planning. See, now comparing this modern urban planning with that of the Harappan planning, if we talk about the road layout, as of now we have grid and radial system, where in Harappan planning they had the grid pattern. The drainage is covered drains in Harappan planning, whereas in modern urban planning it is underground sewer systems. When compared to water supply, they had wells and tanks. Now it is pipelines and reservoirs. Sanitation was they had public baths and drains. Nowadays we have sewage treatment plants. Materials commonly used were brick and stone. Here now we use concrete and steel. The sustainability level was very high in urban planning when compared to that of the modern urban planning, which goes from moderate to high. So I would like to conclude this chapter saying that ancient Indian architecture was very excellent and their engineering planning was remarkable with scientific knowledge, sustainable practices, and advanced structural techniques. The concepts such as Vastu Sastra, temple architecture, Harappan town planning provides a valuable insights for our modern civil engineering, architecture, and urban development. Thank you.